Hey everyone, thank you for joining us today. Today we're extremely excited to announce 3 major new technical updates to the AO protocol that all come together to produce one big thing, which is the support for large language models running in a decentralized environment as part of smart contracts. These are not just toy models, small ones that are compiled into their own binaries. This is a full system that allows you to run virtually every major model that is open source and available right now. That's things like Llama 3 running on-chain in a smart contract, Phi 3 the same, as well as Apple's models and many, many more. So this has been a huge effort to build across the ecosystem, and there are 3 major technical advancements that also form part of this essentially. And so I'm really excited to take you through all of that today. So the big picture is that LLMs now run in smart contracts. You've probably heard a lot about decentralized AI and AI plus crypto many times before. Well, virtually all of those systems, apart from one, which we'll talk about later, are AI as oracles. So having the AI run off-chain and then putting a big trust me bro representation of that execution on-chain that's then used downstream for something. This is not what we're talking about. What we're talking about is full large language model inference as part of the execution of the state of a smart contract. And this is all enabled because we have Arweave as AO's hard drive, as well as AO's hyper-parallel processing mechanisms that mean that you can run a large amount of compute and it doesn't affect me if I'm using a different process. The big picture of where we think that this goes is that it will allow us to create an intensely rich, if you will, decentralized, autonomous agent financial system. Now, in DeFi so far, we've essentially been able to make trustless the execution of the primitives, so the interactions inside a bunch of economic games, things like lending, borrowing, and of course, swaps, token swaps one way for another. This is, we see, just one side of the coin. So if you think about the global financial markets, yes, there are these different economic primitives that are playing out in many different ways. There are bonds, equities, commodities, and so on, and derivatives, of course. But the thing that we really refer to when we talk about the market is not just this. It's actually the intelligence layer. It's the people who decide to buy or sell or lend or take part in any number of different financial games, buying options or whatever it happens to be. So in the decentralized finance ecosystem so far, we have successfully moved all of those primitives into a state where they are trustless, right? So you can take part in a swap on Uniswap without having to trust the operators of Uniswap. I mean, there are no operators at the fundamental level. The intelligence of the markets, though, has been left off-chain. So if you wanted to get involved in crypto and you don't want to do all of the research yourself and take part, what you would have to do is find a fund with whom you can entrust your money, and then they will go and execute the intelligence, and then that downstream flows into the basic execution of the primitives on the network itself. With AO, we think that we know actually that we have enabled the capacity to bring that intelligent part of the market, right? The intelligence that leads to the decision-making, which leads to those executions of the primitives, into the network itself. And so a simple way to understand this might be to imagine a hedge fund or a portfolio management application, which you can entrust your capital to and executes a set of instructions in an intelligent way in the network itself, and thus transferring the trustlessness of the network to that decision making. And that means that an anonymous account, YOLO 420 trader number 1, can create a new interesting strategy and they can deploy it on the network, and you could put capital into it without actually having to trust YOLO developer number 1. This is really, really profound, we think. So you can now build autonomous agents that also engage with large statistical models. And of course, the most common large statistical models are large language models, things that can process and produce text. That means that you can put these inside a smart contract, inside that strategy developed by that person who has a bright idea about how to make money in the financial markets, as a concrete part of it, as a normal part of that process execution. And so you can imagine doing something basic like sentiment analysis. So you read the news and you decide, okay, this is a good time to buy or sell this derivative, this is a bad time to do this or that. And you can have human-like decision-making executed in a trustless way. This isn't just theory. We've put together a fun meme coin, I guess, called Llama Fed. It's a fiat simulator. Basically, the idea is there's a bunch of llamas. They're represented by Llama 3 models inside the network, and they literally act like llamas. They're something between a Fed chairman and a llama is their personality. And you can go to them and you can say, hey, please, dear Fed chairman, kindly grant me some tokens. And they will assess your request. And the large language models themselves, operate the monetary policy in a fully autonomous way and trustless way. We built it, but we can't control it. They operate the monetary policy and they decide who should gain tokens and who should not. So that's a really interesting little application of this that I hope will get the minds racing in the ecosystem of all the other things you can do downstream with this technology. So in order to enable this, we had to create 3 new fundamental capacities for AO, a couple of which are at the base protocol level and another one that's at the application level. These are useful not just for the execution of large language models, but will be far wider and more exciting for AO developers. So very excited to take you through those today. So the first of these new technologies is WebAssembly 64-bit support. Now, this is going to sound a little bit like technical jargon to some of you, but I think I have a way to make it make sense for everyone. So at its fundamental core level, what WASM64 support enables is developers creating applications that use more than 4 gigabytes of RAM. And we'll get into the new limits in just a moment. They're pretty astonishing. But if you're not a developer, you can think of this like someone has tasked you with writing a book. You're excited about the ideas, but then they say, okay, you have 100 pages to write it in, no more. Well, now obviously you can probably express the ideas of the book, but you can't do so in the way that feels natural and normal. You have this external bound set on you, and you have to sort of cater to it. You have to change the way that you write in order to make it work. Well, in the smart contract ecosystem in general in crypto, it's not just a limit of 100 pages. I would say that's kind of what it was like to build in early versions of AO. It was that you had 48 kilobytes in Ethereum of RAM that you could use. This is like someone saying, please write a book, and it's 1 sentence long, and by the way, you can only use the top 200 most popular words in the English language. It's extremely, extremely difficult to build really exciting applications inside this system. Then came Solana, and you could access 10 megabytes of working memory. This is obviously an improvement, but we're talking about basically 1 page at this point. And ICP, the Internet Computer Protocol, allowed support for 3 gigabytes of memory. It was theoretically 4, but they had to lower it to 3 recently. Now, with 3 gigabytes of memory, you can run lots of different applications, but you definitely can't run large-scale AI applications. They just require the loading of a huge amount of data into main memory where it can be accessed quickly. And that's just not something you can do in 3 gigabytes in a serious way. So with AO, when we launched it, we also had this 4 gigabyte memory limit. This actually came from the same place, WebAssembly 32. Well, now that memory limit is completely gone at the protocol level. Instead, the memory limit at the protocol level is 18 exabytes. That's an inordinate amount of storage. It would take an extremely long period of time until that is available in RAM for usage for computation rather than long-term storage mediums. At the implementation level, the compute units in the AO network, the CUs we call them, are now able to access 16 gigabytes of memory. But it will be relatively trivial at this point to remove that and replace it with a much larger quantity. But 16 gigabytes is already enough to run large-scale, large language model computation inside the system. You can download and execute today on AO 16 gigabyte models. That's things like Llama 3, unquantized versions of Phi 3, and many, many others. This is the core component that is necessary to build intelligent language-based computation systems. And now it's supported fully on-chain as part of smart contracts, which we just think is incredibly, incredibly exciting. So this removes the last major computational limitation of AO and subsequently smart contracting systems in general. When we launched AO in February of this year, you might notice in the video that we talk a lot about you have unbounded computation, asterisks, but not more than 4 gigabytes of RAM. Well, this is that limitation being removed. We think this is just unbelievably exciting, and 16 gigabytes is enough to run virtually every model that you would really want to in the AI space right now, and we'll be able to lift that 16 gigabyte limit without any changes to the protocol in the future, and it'll be relatively trivial in comparison to getting WebAssembly 64 running in the first place. So this is on its own just a huge, huge advancement in the capabilities of the system. So the second major technology that enables large language models to run on AO, which we think will be even more impactful for the wider AO ecosystem in terms of what you can build than the first, is Weave Drive. Weave Drive is access to Arweave as if it is a local hard drive inside of AO. Now, what that means is that you can essentially open any transaction ID in Arweave, as long as it is attested to by your scheduler unit, and uploaded to the network, of course. You can access that data and read it into your programs and execute it just like it were a local file on a hard drive attached to the computer. Now, we all know that there's about 6 billion transactions stored on Arweave right now, so that's a huge data set to start with. But this also means that when you're building applications in the future, there's an increased incentive to upload data to Arweave, because now that data can be used inside AO programs as well. So for example, when we were getting LLMs working on Arweave, we uploaded probably $1,000 worth, I would say, of models to the network. But this is just where it starts. The number of applications that you can build now that you have a local file system inside a smart contracting network is just enormous. So this is really, really exciting. Even better, the way that we built this system allows you to stream data into your execution environment. And this is a little bit of a technical subtlety, but you could imagine it back with our book analogy like this. Someone speaks to you and they say, hey, I would like to access a piece of data inside this book you have. I want to get a figure from that book. Well, in a naive system, which even frankly for a smart contracting network would be a huge step forward from the rest of the competitive landscape's position at this point, you would give the entire book. Well, obviously that's not very efficient, and particularly if that book is something like a large statistical model that has many, many, many thousands of pages. It's extremely inefficient. Instead, what we did with AO is essentially make it so that you can read bytes directly. So you would go directly to the figure in the book, and you would copy just the figure out into your application and execute upon it. So there's real efficiency to the system. It's not just an MVP even, I would say, a minimum viable product. It's a well-featured, well-built mechanism for access to data inside the network. So you have an unbounded computation system and you have an unbounded hard drive. You stick them together, you have a supercomputer unlike has ever been built before, and you make it available for everyone to use at the minimum viable cost. This is essentially the state of AO today, and we're just unbelievably excited about it. The way that this is implemented is also at the operating system level. So we made Weave Drive into a sub-protocol of AO. That's a computation unit extension that can be loaded by anyone. And this is interesting because it's the first extension of its kind. AO has always had this ability for you to have extensions on the execution environment. Think of it like when you have a computer and you want to stick some more RAM in it, or you put a graphics card in, you physically put a unit inside the system. Well, you can do that with AO CUs, computation units, and that's what we did here. And so at the operating system level, you now have access to a hard drive, which is just a file system that represents the data store on Arweave. And that means that not only can you access this data inside AOS, the normal way of building applications with AO, but you could actually do so from any application that is brought to the network. And so this is a widely applicable capability that is available to all people building inside the system, whatever language they want to write in, whether it's Rust, C, who knows, Lua, Solidity, anything. They can all access this as if it is a native capability of the system. And at the same time, it essentially, in building this, it forced us to create the sub-protocol protocol, the way of creating other computation unit extensions so that other people can build exciting things in the future. And we're about to hear from an ecosystem project that is doing just that later. Now that we have the ability to run computation on arbitrarily sized memory sets and the ability to load data from the network into those processes inside AO, the next question is, okay, well, how do we actually do the inference itself? So because we chose to build AO on top of WebAssembly as its primary virtual machine, it's very easy to get, relatively easy to get other existing pieces of code to compile and run in that environment. And because we built WeaveDrive such that it just exposes a file system at the operating system level, then getting llama.cpp, which is an open source LLM inference engine to run on top of the system, was actually relatively trivial at that point, which is really exciting because it means that not only will you be able to run this inference engine, but you could run many others easily too. So the final component in this new stack that enables large language models to run inside AO is the large language model inference engine itself. We ported a system called llama.cpp, which sounds a little bit, esoteric, but actually it is the leading open source model execution environment right now. Well, we ported it to run directly inside AO smart contracts. Once we had the capability to have arbitrary amounts of data inside the system and then to load arbitrary amounts of data from Arweave itself, then this was just relatively trivial, actually, in comparison. One of the interesting things we did here to enable this is also work with what are called SIMD, same instruction, different data, computation extensions, which allow you to run these models at a far faster pace. And so we've enabled that as well. And this means that, yes, the models are running on the CPU at this point, but they run pretty quickly. They run quickly enough that if you have asynchronous computation, then it should work for your use case. Things like reading in signals about news and then deciding what trades to execute would run fine with the system as it stands. But we also have some exciting upgrades on the way that we'll speak about in a little bit regarding other mechanisms of accelerating with GPUs, LLM execution. So llama.cpp allows you to load not just Llama 3, the leading model from Meta, but also any number of other models. Really, 90+% approximately of everything you can download from the open source model site, Hugging Face, will run inside this system. Everything from GPT-2, if you so desire, through to Phi 3 and more niche, Apple's own LLM system, and many, many more. So we have the framework in place now so that you can just load up any model from Arweave. You can upload it. I was using R Drive to upload the models I wanted to run inside the system. You upload them, they're just normal data, and then you can load them into your AO processes and execute them, get the results, and work with it however you like. So we think that this together is a package that enables a huge number of applications that just weren't possible in previous smart contracting ecosystems. And even now that it is possible, the number of architectural changes that would have to be made in order to make this run in an existing system like Solana, it's just not on the roadmap. It's not what they're focused on. It's hard to say it would be impossible at this point, but it seems highly improbable that it will ever end up in that direction. So in order to demonstrate this to you and make it feel real and understandable, we've created a simulation, Llama Fed. Basically, the idea is that we get a council of Federal Reserve members that are llamas, both in the sense of being Meta Llama 3 models with a 7 billion parameter variant. And we also tell them that they are llamas. And also they should be half like Alan Greenspan or a Fed chairman. And essentially what you can do is you can go into this little environment. Some of you will be familiar with this. In fact, it's just like GatherTown, where we're working and meeting today. And you can talk to the llamas and you can say, hey, please, Mr. Llama, can I have some coins for this very exciting project I have to make some hay and distribute it to the community? And depending on which llama you get, they might like this idea or not. And so you burn some Arweave tokens that are wrapped R, thankfully provided by the AOX team, and they will mint you some tokens based on whether they think that your proposal is good or not. So it's a meme coin where the monetary policy is fully autonomous and intelligent. A kind of stupid form of intelligence, but fun nonetheless. It will essentially judge yours and others' proposals and run a monetary policy. Now, it's silly in this case, but you can see where this goes. It's very serious when you make it not just that, but analyzing news headlines and making intelligent decisions, or working with customers on support and returning value, this type of thing. All of that is possible now within smart contracts themselves. So Elliot is now going to take us through what he's been building with Weave World and how to meet the llamas and try this out for yourself.
Hi everyone, I'm Elliot Sates. Today, I'm going to show you Llama Land, an on-chain autonomous world running inside AO. It's powered by Meta's open source Llama 3 model. The conversations we are seeing here are not just between players, but also fully autonomous digital llamas. For example, this llama is a human, but this llama is an on-chain AI. This building contains the Llama Fed. It's like the Federal Reserve, but for llamas. The Llama Fed runs the world's first AI-driven monetary policy and mints llama tokens. This guy is the Llama King. You can offer him wrapped Arweave tokens and write a plea for a chance to gain some llama coins. The Llama King AI assesses and decides how many, if any, llama coins are awarded. There is zero human oversight of the Llama Fed. The monetary policy runs fully autonomously. Each agent in the world and each of the rooms themselves is an on-chain process on AO. It looks like the Llama King has granted us some tokens. And if I check my Arc Connect wallet, I can see that they're already there. Nice. Llama Land is just the first AI-powered world implemented on AO. This is the framework of a new protocol that lets anyone build their own autonomous worlds, limited only by your imagination. All of this is 100% on-chain, only possible on the perma web.
Thanks, Elliot. So, what you just saw was a demonstration of not just a large language model taking part in financial decision-making and running a monetary policy, of a fully autonomous system. There's no backdoor, we can't control it. It's all run by the AI itself. But you also saw a little universe, right? Something that you can walk around in, a physical space, and a place that you go to where you can engage with this financial infrastructure. We think that, while it's just a fun little demo today, there's actually potentially something very interesting here, which is that these places, if you will, bring together many different people that are using financial products. So what we've seen in the DeFi ecosystem so far is that if someone wants to take part in a project, what they do is they check it out on Twitter first. Perhaps they go to the website, they engage with whatever primitives the game in question has, and then they join the Telegram group or the Discord channel or speak to other users on Twitter. And this makes a very fragmented experience that we're all playing in together, where we're jumping between different applications. One interesting idea that we're playing with is, well, what if you just have user interfaces for these DeFi applications where their communities can gather and govern this autonomous space that they're collectively accessing, because it's all on Arweave, it's a perma web app, and conjoin the experiences. So imagine that you can go to something that looks like an auction house, and you hang around with the other users that like that protocol, and you chat with one another, and as activity is happening inside the financial mechanism process on AO, essentially, you can chat with one another. The community and the social aspects are conjoined with the financial parts of the product, essentially. We think it's pretty interesting, and it also has wider implications even than that. What you can do here is you can build an autonomous AI agent that just wanders around this place, this Weave world, if you will, and engages with different applications that it finds and engages with different users. And so if you were building a sort of metaverse, one of the first things you do when you're creating an online game is to create NPCs, right? Well, here the NPCs can be generalized. You have an intelligent system that just wanders around the world, engaging with stuff. And so you don't have that cold start problem of no users, potentially. You just have little autonomous agents that are trying to make money for themselves, trying to make friends, just like a normal DeFi user, which are engaging with the environment. We think this is very interesting, although quite bizarre for now. We'll see where it goes. So on the horizon, we also see the opportunity for speeding up LLM execution inside AO. Earlier, I spoke about this idea of computation unit extensions. That's what we use to build WeaveDrive. Well, it doesn't just stop at WeaveDrive, right? You can build any type of extension for the computation environment of AO. And there's a really exciting project in the ecosystem that is looking to address this now for GPU acceleration of LLM execution. And that's Apis Network. I'll let them explain.
Hi, I'm Mateo. Today, I'm excited to introduce Apis Network. Apis Network is building towards a decentralized, trustless GPU network dedicated to providing reliable, efficient, and low-cost computational power for AI training and inference. By leveraging Arweave's permanent on-chain storage, we offer an open-source AO extension that provides a deterministic execution environment for GPUs, with an economic incentive model for decentralized AI using AO and Apis tokens. Apis will use GPU mining nodes to competitively execute optimal trustless model training on Arweave and AO. This ensures that users can use the best AI models at the most cost-effective prices. You can follow our progress on X at Apis_network. Thank you.
Okay, so this is the state of AI on AO today. You can go check out the Llama Fed and try it for yourself. Have fun with the LLMs that are running in the system. There's documentation as well if you'd like to build your own LLM-based applications inside smart contracts. We think this is the start of what should essentially be a Cambrian explosion of bringing the intelligence of markets inside the trustless execution environments that we're used to inside DeFi. It's just now we have so much more capacity and so many more capabilities, and also, frankly, building on it is far easier because of those capacities. Yeah, we're just very excited to see how this goes. So thank you for joining me today. Excited to speak to you again soon.